Okay, so here's kind of the stuff I've been working. I've been working on enabling multiplayer presence. So I can kind of give you a demo of that. So I'll start my server. It's in the middle of it. I'm not fully done. What I've accomplished so far, I'll give you a little bit of a presentation here. So yeah, you should subscribe to the YouTube channel. It has all the previous videos. So I've been working on passing a camera, storing user position, creating a spawn point. So I'll go over these. Let me close some windows. Okay, so kind of have this homepage. Welcome to the XR space. Create and share experiences in an extended reality space. This is just a link back to the homepage. Does nothing. This gives you a list of spaces, and I'll just delete all the spaces. So you can create a new space, and modal pops up. You can call it ABC. Description is not required. It will automatically create a random slug for you that begins with ABC. So if you go and edit it, you can rename your slug. If no one's using ABC, you can use ABC. Type whatever description. And then we have some other options that I added here. So one is clear color. It is actually the color which clears the graphics buffer. So right now it's green, and you can put just about any color you want. So we could have something more dim, like 0A, I guess. This is probably a very dim green. You can have a fog color and a fog density, so I'll leave those the same. So this is close to gray or white. So if I save this, and then we enter the space by clicking enter, you'll see that this is that really dim green. You probably can't see it, but I can come in, open the menu. I can add a couple new things. So I don't know if you saw this. You can add a grid. If you click add, where's our grid? I can't see it. Add a box. Huh, I can't see the box either. Oh, let me try changing that. So I can click on the space menu. Let me try changing the clear color again. I'm not sure if that's the issue. So this is bright green, and and it should be persisted, right? So if I look at this again, it's bright green. Refresh the space. Oh, okay. Oh, okay. We couldn't see it because we were just like totally inside its space, I think. Let me try making that clear color more dim again. Clear color. It's possible that if it's too dark and I don't have lighting in the scene, it was just too dark to see. Let's try 0, 1, very dark. So saving that didn't actually send a message, so that's why I have to refresh it to see anything. Oh, now I do see it. Okay. And here's the new thing I added, which is the spawn point. So if we pick spawn point and we add this, the spawn point is just where you want the camera to begin with. So if we click on the spawn point, there's only one component on the spawn point, whereas box has color. So you can change the color to, let's say, red, and that turns red. The spawn point is not something you see. It's a position where you're located, and the position is right now very, very low. We're actually right in the ground at 0. So if we want the position to be maybe 2 meters tall, we can put 2. And now if we refresh the screen, I think we'll stay in the same spot because I actually added it to session storage so that if you do refresh the screen, you're not respawning from the spawn point every time. So if we, however, close the like actually do a hard reset and hard reload coming back here, the session is considered a new session. So now if we come in here, and if we come in here, let me just query that. We can say session storage. If you look here, this is odd. How do we get this position? Session storage, if you say get item with a position, here's our position, which is a little bit left, barely off the ground. So this is unusual. Why are we so short here? Let me check this spawn point. Okay, we should be here. Try again. So here. Oh, it's still in here. Session storage. Do I have to? Oh, maybe I have to close the tab. Local storage. Okay. Oh, okay. I guess you have to close the so a refresh or any navigation within the same tab doesn't lose the session storage. You actually have to open up a new tab. Okay, so now I use the session storage. So if you had a bad connection and you want to refresh the page, you're starting close to the position you were in. So on every camera movement, I stash that JSON snippet in there. So now it's a fresh load, and that is interesting. We're looking straight down. Oh, okay, because the camera is pointed at the origin. Okay. The other thing I did was I'm sending the message to other browsers, but let me fix this issue first. So we can go to our files here. Here's we only have one JSON file, which is the orchestrator. And what's happening is we want to create the camera first. But first we do find my position, which looks inside the session storage. So if you look at find my position, it does Windows session storage, say get the item. And if this is nothing, so if this is null, then you'll ask the entities. So find the spawn point will look through the entities coming from the database, and it says which one of you is a spawn point. And if you find one, then you grab the position of that spawn point, which right now is +2 in the Y dimension. It will we'll store that in the session storage. And then otherwise, we'll just, we have a previous location. We'll return this as find my position. So this find my position, is, I don't know why this is just floating out here. This returns something, and we're not using it here. Okay, so we don't actually do anything here. This is a bit weird. We don't need that here. Okay, where's the other usage of it? Here we go. Okay, so when we want to join with the backend, we're creating a space channel. We're handing the position that we stored locally in the front end to the backend. And then in the backend, we're storing it in the ETS table, so that we can in the future broadcast all positions. We'll know all positions on the server, so we can broadcast that to everybody. So that's something we'll eventually use. And okay, here's where we're using it. Create the camera. So when we're creating the camera, this is part of the initialization process. We have a position which we either loaded from the spawn point, which we defined in the editor, or we're getting the last known position from the session storage. And now we want to create the camera at that location. So we convert this position into an array and we hand it to the camera. But it doesn't have a pointer. So here, the set target said set it to the 0. And that's why right now when I loaded it, we're at 2 meters high and we're looking straight down because it says set target down here. So if we remove this, I think we may just be pointed straight ahead. So I'm going to comment this out, and we'll see what happens. So we'll come back here, and yeah, I think it solved it, because now let's just close this again, get a clean slate here, go into spaces. If I load this here, I'm pointed straight ahead. I'm right on top of the origin, so if I back up a little bit, I'm over here. Okay. So some of the things that I did was here I create an event bus signals, and it's just it's called an RX subject. A subject is something that you can push things in, and you can subscribe to things coming out. And the type of this is signal event, which has an event name, which is a string, and a payload, which is some arbitrary object that can have like position, rotation, color, or some other stuff that we just remain undefined here. We can maybe type these out so that we can join them with ORs if we want to be more strict, but for now it's just an anything. And the way in the beginning of the construction, we make a couple of connections. So we establish an event bus so we can use it later. This is some boilerplate for Phoenix to connect to the WebSocket, and it passes a user token that we have initialized in the session so that it's secure. It's something, and then on the back end we can also get back the member ID which we have set in the session. All that is used to say that it's setting up WebSockets, and we identify the user with some random ID. Then from the initialization, we have a serialization of the space which we pass to the front end, and we're kind of passing back. What that means is that when we create a space using this editor here, we're creating a record in the spaces table, and every time we go in there and add some of these things, these entities, they're being saved as new records in the entities table. So here we have, let's say, a cone. I'm going to put that here. So now we have a cone. We can move that up. So let's move that a bit up in the y direction and move it left in the x direction, whoops, in the -5 direction, and then we can change its color to maybe green or whatever this is, yellow. Okay. And so if we grab the slug, which is ABC, or actually we can just say space equal repo all space. So this will be spaces. This will give me back all the spaces, which we only have one space, and therefore space equals list first from spaces. And so we have a way of serializing the scene. So we have this function called serialize, and we can pass it a space, and it gives us this JSON output. This JSON output is placed into the HTML of the template. So when somebody hits this URL, we go to this router. So this part here could be any kind of string. We're calling that the slug. It goes to space controller. Space controller is a controller with just one method in it, or function, show. It deconstructs the slug, and we look up the space by the slug. Oh, so I could have done this. So I could have done spaces, get space by slug, give it ABC. This returns a space. So here, if we don't find a space, then we're going to redirect them. Like, I don't know what you're talking about. So that protects us from, okay, I want to go to this space. that space doesn't exist, we get bumped back over here. Unrecognized space slug in the URL. Okay. But if the space is found, we're going to start our server. So nudge space here is just going to call the supervisor, and we're going to start a space. So we're going to have a supervised space for any variables we want to hold there while we're there. Otherwise, and not otherwise, but in addition to, we're going to render this template, show HTML. So if we look at the show HTML of the space, we render some stuff for that menu on the right side. We render the space canvas, and then here we render some script where we pass the serialized space, or we're creating a variable on the window object called serialized space, which contains spaces serialized. So again, that's this string here, spaces serialized. This mumbo jumbo here defines every entity. It defines every component within each entity. So all the stuff we have in the form, like the color, the position, the rotation, the scale, all of that's passed to serialized space. And so now our orchestrator is loading that back in. So this happens because in our layout, it's picking up this orchestrator file. And at the very end of this file, this is just a script import at the top. But at the very bottom, it says, okay, when your DOM's finished loading, get that serialized space and pass it into the constructor of new orchestrator. So the new orchestrator has everything that it needs to build the scene. We have everything serialized here. It can iterate through these entities here, one at a time, draw where the cube is, where the sphere is, where that cone is, the grid. It's drawing all that stuff. And then it's going to call start. So if we look at this orchestrator, this is what it's doing. It's setting up the channels. It's saying that entities comes from that serialized space entities. And then we have some things that are settings, which are not things you pull into the scene, but the thing like clear color, like fog. So if I go back here and I edit this space, these are properties that are in a JSON column on the spaces record, not as individual entities. So this is kind of cool. Fog is something that you can control for the whole scene. So we're at 0.01 fog, but if I want to 0.1 fog density, save this, and then I enter this space, now you see it's much more foggy in the scene. And I think the reason why we don't have a skybox out here, which is why we don't see the sky here, but because it needs some kind of thing to be a shader against, and this thing isn't anything yet. So maybe one of the things we need to add into the settings is a skybox. What else? So we established the space channel, which is for communication. And this is the topic. So anytime you create a new channel, you want to say, anyone else who's joining this space, we want to talk on the same channel so that when we broadcast messages, we're on the same topic. And so the topic is really just the slug. So for us, it's ABC. And then we're sending in that initial spawn point. So this gets handled by the space channel bit of code and background. So we're joining the space with the space : slug, and we get the parameters. So the parameters are going to contain the position. So all we do is that we'll process this. We'll send ourselves a message with those parameters. Meanwhile, we'll just send this message back to the front end, which here it was just testing some stuff, so we don't need this anymore. Yeah, this was just testing the stuff was hooked up. So on the front end and the orchestrator, when we join, we just say, oh, okay, you joined successfully, print this out. So over here, you'll say hi. It'll say hi, hello, hi there, what this stuff is. It's not really doing anything. I put the channel on the window object just so I could do some debugging. That allows us to do channel.push, and I can send any kind of message to the backend. But some of the messages we're paying attention to on the front end are member moved, component changed, entity created, entity deleted, which these things are broadcast when people are changing the form, right? So one of the things that we could do is we could listen for settings changed, and then we can parse those things. So we need to send that message whenever we change the settings, right? So maybe we can do that here in spaces. Here's where we're calling change space, which will go through and it will cast name description and cast embedded settings. So how do we broadcast? I think to broadcast a message, we need a thing. Slug component change. Okay, this is all we need. We need the topic, the message, and the payload. Okay, so if we go to spaces and we're saying that change space. Oh, this just gives the change set, right? This doesn't actually change anything. Yeah, that's just giving you the change set. So where are we using change space? Let me go to the space form. So we've got live edit pages, which space live, when we edit it, it's inside the form component. So we go validate and we save a space. What does that do? Save space here. Okay. You're editing it, space updated. So we are calling spaces update space. And okay, so we can do it in this function here. Okay. So we can say broadcast change here. Broadcast space update. And if you look in the previous area, we're saying if you got OK in a space, then put this in the flash and all that kind of stuff. So we're looking for OK something. So we can create maybe a private function here. That's broadcast space update. And then it takes an argument which is OK, and we have the space. And for anything else, we're just going to pass it along. I guess maybe there's a better way of stating that. So in the OK, you got something case, we want to do this. We want to broadcast to the space slug. That's the topic. And we want to say that space changed. And maybe space settings changed. What was the thing we wanted to hook up on? We hadn't said anything yet. Let's say space settings changed. And then in here, we can pass, whoops. Where did we go? Here we'll just pass the space settings. Okay, then in the front end, we're looking for space settings changed, and maybe we'll just console log this out. So this space channel on, space settings changed. We'll get something, and we'll just console log space settings changed with the params. Okay, so let's refresh this. We go here, we can go to the space. This UI is a little clunky, we gotta clean this up, but let's say we change the fog density to 0.5. We save it. Oh, we got an error here. What happened? No case clause matching OK in form component 47. We got down here, repo update should give OK in a struct, OK in this. Can you guys see anything?
I don't know what we're looking for. Like there's a pattern matching that it doesn't match what it's supposed to match. Ooh. Got it.
Okay, so it did update the space. Okay, so we got as far as this part. I think something worked here, space settings.
Can you pattern match like that with the braces, like OK and space?
I think so.
Don't you need to set it to, oh, okay. Like, don't you need to do like equal something? I'm not sure.
I think it can be a, I think it
Yeah, never mind.
But let me see if there's a thing as space settings. So if we did, do we still have a space here? Space settings. Okay, there is that. Okay, I want to give that to the front end. And what would happen if I do this? EXR web endpoint broadcast space ABC settings change. This can be anything and space settings. Does this have an error? That's okay. Oh, the return result of this is screwing up whoever wanted it, because this is giving okay, and that thing needs okay with the space. We broke the chain here. Okay, so we want to do that. Okay. So now we are sending it to the front end, and I want to see if we get this as a message. Space settings change. We do get this. Very good. So we need to process that in the front end with I think we can just maybe do this here. This scene. clear color equals params clear color this scene dot fog density equals params fog density this scene dot fog color equals params fog color. Whoops. Save that away. And now if I just move this, so if I were to change the fog and go here, edit, fog color, put it down to 0.1. I see nothing. What happened?
Anything blow up?
Possibly. Let's try changing the clear color. Edit. Edit clear color. Oh.
What does the IEX say? Terminal. Oh.
IEX didn't have a problem with it. Let's try changing one thing at a time. So let's just try, actually, let's not do anything. Comment that out and just try this in the console. If we have scene, oh, yeah. You can't, okay, these are in a different format because, got it. So, all right. Actually, how did I process them in the first place? So we go space channel, and then we go to build the scene. So we say, recreate the camera, create the scene. So we create, here we go. We need to do this stuff. Yeah. So we could extract this out to a function, which is process scene settings. And let's take in some arguments. So let's say we have the clear color, which is number, I think. What are we giving back? Whoops. Okay, it's a string. It's a string float. String fog color is a string, and then a fog density is a number. And so we want to grab these things, cut and paste. So this will take this settings. So we're going to say this process scene settings takes this settings clear color and this settings fog color and this settings fog density, and then change this to clear color, change this to fog color, change this to fog density. So this part should be the same, and then we'll reuse this process scene settings up when we get a message from here. So do this thing, same thing, we'll just change this with params. Alright. So I'm going to change the clear color. Go here, go here. The clear color is too bright, and bring it down to a 0. Let's do that, save. Okay, very cool. Let's change the fog density to like 50% fog density. So bright. Bring it down to 0, 1. Okay, cool. So now that's interactive. Okay, but we were working on VR presence. So right now I have, after we created the camera, what we do is there's this hook that Babylon.js provides. It's called onMatrixChangeObservable, and you pass in your own function. So the function is taking the camera and saying, I can get properties of this camera every time the matrix changes. So every time you move it around, you're getting a new, this is being called. So what I'm doing is I'm getting the camera position object, converting it into an array, then I map and I kind of truncate the digits because it was like 10 decimal points after the period. So I kind of just made it 5. We don't need that much precision. And then I pushed it into the event bus. So I said, next, on the signals, give an event called camera moved. And that allows us to subscribe to it and do things like throttle it. So later on, I subscribe to the signal in after we've created the scene. I say, go to the signals and pipe and look for anything that matches camera moved. Throttle it by time for every 100 milliseconds only. So we're not doing this on every frame. And then do something. So the way RxJS works is you have a signal and you can pipe any number of functions, and then you finally end it. This is the time when you do an effect, is you say, now we take that space channel and we push this message, which would be camera moved, and then the payload, which right now is just a position. At the same time, we're going to store into the session storage our new position. So if we reload, we're going to come back at the same position that we are. And now we're not doing anything with that. So we're pushing it, and then on the space channel side, anytime we get a camera moved, we're just broadcasting. So there's two kinds of broadcast function. One is broadcast. That will send it to everybody, including ourselves. But because we already know where we are ourselves, we don't need to receive that message. So there's also broadcast from, which is send to everybody except the sender. So here I changed this to member moved, and then I put in the member ID, which is ourself, and then the position, which we got from the payload. So then in our orchestrator, we're receiving that member moved back as a different client that's running the same code. We get member moved, and here we're just logging out the member moved. So if we want to see some representation here, we want to draw something and then update its position. So one way of doing that is, first, we need an object. So some part that you miss is I added presence state and presence diff. This is part of Phoenix tracking. And the way this works is you have space channel. And then when you join the space, there's this after join, go do some stuff. And that's handled over here. And one of the things it does is it, forget about this for a moment. This is just grabbing an ETS table, an ETS table, in order to stash where you are. We're not using this yet. But this is the presence track business. So what this does is it links a process to this thing so that when this process dies, it will remove from a database that you are connected at all. So this will put into the database that we're tracking this process through this member ID. And then after the join, we send a presence state. And then if this process dies, if somebody closes the tab, we'll get a presence diff with leaves and joins. So we're not doing anything with those yet except console logging them to the screen. So we'll see a presence state and presence diff. So if we look in here, and you'll see it here. So we get a presence diff right here. Then in the joins, we see one for ourself. We joined a presence state with ourself in it. Metas. Okay, that's keys. Okay, so the keys will be our unique. So K7F4, that's us, ourself. And we want to draw, maybe we want to draw ourselves because we can see ourselves. But maybe we want to join everybody else. So do we know our own member ID? I don't think we do. We don't have our own member ID yet, I think. So maybe that is something we need to pass in. Yeah, I think we need our own member ID. So we should add that. Member ID, the string. Public. Which makes it part of the instance class. And how we get that? We're going to get that through let member ID equal window member ID. Pass that here. These don't change, so I could just call them const. So we need to set this, and where are we setting that? We're setting that in the show HTML here. So we can set window member ID is equal to, so we need member ID. And where does this come from? This comes from the space controller, where we're passing in these variables here. So I believe it's in the con. So in our router, we have these plugins, and all of these plugins will run for each request, right? So when you have this stuff, it's piped through browser, which is this pipeline. And here I wrote a plugin called maybe assign the unique ID. So that's imported here. Maybe assign unique ID from plugs identity here. So I wrote a module here. So given the connection, you'll get the session out of the connection for unique ID. And it might be there, it might not be there. So if it's nil, then create a random unique ID and put that into the session for next time. And then assign into the connection unique ID. Otherwise, if it's already in there, just assign it into the connection unique ID and return the connection. So that means that in our controller, we can actually it's already in the connection. This is assigning other things into the connection. I think we already have it in the connection as unique ID. So member ID con assigns member ID. I believe this will work. Member ID not available in template. Let me refresh this. Member ID not found in unique ID. Sorry, unique ID. I don't know why I called them different things. Maybe I should name them the same. So in the session, I called it unique ID, and out here in the variable, I'm calling it member ID. Maybe I should fix that later. Okay, so now if you look at the page elements in here, here's the serialized space, here's the member ID. So now that's passed into the orchestrator. We now have a sense of who we are, and we can draw everybody else. So in the orchestrator, when we get leave, or let's say presence state or presence diff on joins, what we want to do is object keys on params. Each key is going to be the unique ID of a user, and then filter where the ID is not equal to this member ID. That's all the IDs except ourselves. What is this complaining about? Oh, filter needs a function. And then do something, right? So now map over them. Map over them. And this is, yeah, again, this is ID. And what do we want? We want to like maybe create a box. So we can do babylonjs.create Meshbuilder create a box, and then we can give it a name here. So the name can be like avatar, and we can give it the ID, and then that should be the default. So let's just see what happens. We're just creating a box, and there should be a box somewhere. It's got to be at the origin because we didn't tell it anywhere else. So here, if we refresh this, we're not drawing a box for ourselves, so we need to open up another browser. So if we open up Firefox and we go to the same place, okay, we see a box for this guy over here. But because this guy joined first, when this guy joined, he doesn't get a present state. Present state is only given once on the join. We get a presence, what do we get? We get a presence diff. So from our point of view, P3, that's this guy over here, we need to handle their join. So we need to do the same thing, but for join. So we have present state, do that. Then on presence diff, do the same thing, except it is, there's a joins key there. Presence diff. So we're going to do that on params.joins. Right? Then we're going to draw a box. So now both sides should have a box. Right? So this side has a box. This side has a box. If we close one, we should remove the box, which we haven't done yet. But I kind of wanted to move the box. So if I move left and right like this, we should see on this side the box move. And then we can do this using the member moved, right? Because we have the member ID. So we can do scene, this scene, get mesh by name. Now remember, we named it by when we used the Meshbuilder, we gave it the name of avatar and then the member ID, right? Right? We did this. So we should be able to get the mesh name here. So let mesh equal this. And so if we can find the mesh, then do what? Mesh dot position equals, and this is, I think it's an array. So mesh position. Actually, let me console log. What is it? I forget what it is. Oh wait, getting member moved. We have this. Getting member moved. This is a. Oh, it's just an array. It's just an array. So okay. So then mesh dot position from array position. So if we bring in this, there we go. Okay, so it's moving. Okay, so we kind of have VR presence, sorta. We haven't added rotation, so rotation is not being passed, it's not being stored. And yeah, that brings us to the hour. Pretty cool. We've kind of restructured what we've done before, but with documentation and at least video documentation. So any last minutes remaining? I'll open it up to questions. Let me stop sharing. Stop streaming. Whoops. Can you guys still hear me? And I'll turn on my. I'll stop this recording.
Yeah.